Hello everybody and welcome back. Today our topic is going to be about the comparison of the dynamics of the left ventricle and the right ventricle. So we're going to start talking about the right ventricular pressures and flow. The right ventricular pressures and flow has a peak systolic pressure of 30 mm mercury and an end diastolic pressure of 6 mm mercury. For the left ventricular pressure and flow, there is a peak systolic pressure of 130 mm mercury and an end diastolic pressure of 10 mm mercury. The spiral bundle contraction wrings the blood out of the ventricles. The contraction of the apex of the bases of the ventricle propels blood upward to the aortic and pulmonary valves. Now we're going to be talking about the left ventricular contraction. The left ventricle has a conical shape of the lumen, which gives the left ventricle a smaller surface to volume ratio than the right ventricle. This conical shape helps the left ventricle to generate high pressures. For the right ventricular contraction, the right ventricle has a small movement of free wall, which ejects a large volume due to its large surface area. The right ventricle ejects a large volume at low pressures. The right ventricular contraction steps are three. The first one, which is the free wall, shortens. The second one, which is the free wall, moves toward the septum. And the third step for the ventricular contraction is the septum moves toward the free wall. Now for the wall stress. The wall stress is the shortening of the contractile fibers which generate tension within the ventricular walls. Stress develops when tension is applied to a cross-sectional area. This is expressed in force per unit area. The geometry of the ventricular cavity is important in determining the wall stress, as shown by the Laplace law. This law is wall stress is equal to pressure multiplied by the radius divided by 2 times the wall thickness. Wall stress is an important determinant of myocardial oxygen demand, which causes the ventricle geometry, which influences the myocardial energetics. Wall tension is the force acting on a hypothetical myocardial slice, tending to pull its borders one towards the other. The wall stress is the force acting on the surface unit. The synchronicity of the left and right ventricular contraction is very important for the efficiency of the ventricular pump. The mechanical consequences of the left bundle branch block is the left and right ventricle activation is asynchronic. The initial contraction of the ventricle's diastoles are at very low pressures, and the left ventricle has a free wall contraction with high pressure. So this was everything for today's lecture. Thank you very much and hope to see you soon again in the next video.